Okay, now we're working on number 4, mechatronics example, looking at loads, actuator loads. In this case, Scott's printing a 3D printing an anthropomorphic hand, plastic tendons, extruded nylon, 0.1 centimeter in diameter. Sounds small, Scott, honestly. Connected to an RC servo horn, 1 centimeter radius, and this servo motor. Will the nylon fail? All right, first, let's create a little schematic. So we got Scott's got a hand here, and his hand has these tendons that run down. Tendons come down, and then down here somewhere it attaches to the horn on a servo. All these horns I see have like these 4 prongs, but he's just connected to one of them. And that goes back to some RC servo he has back here. Okay, but what we're interested in is this shaft. So from there we can do our free body diagram. Some little shaft. Let's just assume, it didn't really say, but let's just assume it's a little column, a rod, circular rod. So I'm pulling down and pulling up with some force. Okay, what's that force? Well, I need to calculate that. So say I had the servo motor horn here, and that servo created some torque, which is related to the force through this R cross F. Note that R is perpendicular to my F. Okay, so my F is here, and my R is here. So they're going to be perpendicular, so I can rewrite this as torque is R times F since they're perpendicular. So my torque is a 8 kilogram centimeter. So it's 8 kilogram centimeter. I got to multiply that times 9.81. So that's Newton centimeter equals R. The radius was 1 centimeter times a force. Or my F is simply 8 times 9.81. Oops, I need that. .5, so F is 78.5 newtons. That was centimeters, Newton centimeters. Okay, now I'm going to look at the stress. The stress that I have is an axial stress. And we noticed from our notes, the case of axial stress, that's given as force over area. In this case, the area, the force is 78.5. In this case, the area is pi r squared, which is 78.5 pi, 0.1 centimeters. So let's write that as 0.1. Let's write that in meters. So it's 0.10, okay. It's 0.05 centimeters. So let's write that as meters. So it's going to be 0.0005, and that's going to be squared. Okay. So let's see what that gives for us. Gives us 78.5 pi divided by 20. Pi times 0.0005 squared. 99.9. That's 199.95. About 100 megapaw. Will that fail? The ultimate is 45 megapaw. That's, you know, so my sigma has to be less than or equal. My sigma max is my yield stress divided by my factor of safety, which I guess let's just assume is 1, which is 45 megapaw. That is 100 megapaws, not less than 45 megapaws. So this, his tendon fails. It clearly fails. Not even close. And that doesn't even assume a reduction for 3D printing. Okay.